Hello students and welcome back to Science Space. I am Chaitanya Somaiya back with another video on the chapter Electrochemistry from class 12. In this video we will cover the topics, the different types of electrodes that are used in an electrochemical cell, the electrochemical series, and then we will study the Nernst equation. Nernst equation will be a very important topic as it will be helpful for solving the numericals of this chapter. Watch this video till the end so that you get a summary on the chapter and there are some important questions given in the end of the video. Note the questions, solve them, and if you have any doubts you can ask them in the comment section below. While studying the different types of electrodes that are used in an electrochemical cell, we will start from metal-metal ion electrode. As the name suggests, it consists of a metal rod that is used as an electrode and the salt solution of the same metal used as an electrolyte. So while studying metal-metal ion electrode, we will go through the electrode reactions that are taking place in the electrochemical cell. There are two types of electrode reactions that occur. The first is the oxidation and the second is the reduction. What is oxidation? The loss of electrons by the metal rod is called oxidation. And what is reduction? The reverse of oxidation, that is the gain of electrons by metal ions present in the electrolyte. It is called reduction. So these two processes take place in each individual half cell in an electrochemical reaction. Then next, what will be the cell representation for such kind of metal-metal ion electrode? So there are two types of half cells, that is the anodic half cell and the cathodic half cell. Anodic half cell को oxidation half cell भी कहा जाता है और cathodic half cell को reduction half cell भी कहा जाता है. Anodic half cell oxidation half cell इसलिए है क्योंकि यहाँ पर loss of electrons हो. Loss of electrons होने के कारण इस electrode का जो representation है वो कैसे बताया जाएगा? Metal in solid form will produce Mn positive aqueous ions. जितने नंबर ऑफ इलेक्ट्रॉन्स रिलीज हुए उतने पॉजिटिव आयंस प्रोड्यूस होंगे इस इलेक्ट्रोड पर. एंड देन इन कैथोडिक हाफ सेल इट इज आल्सो कॉल्ड एज रिडक्शन हाफ सेल. व्हाट इज द रीजन बिहाइंड इट? द n number of electrons are gained by the metal ions present in the electrolyte solution in the cathodic half cell. So it will form solid metal atoms which will be deposited on the metal electrode. यहाँ पर क्या होगा? n number of electrons gain किए जाएंगे by metal ions. वो metal ions कहाँ पर present है? Into the electrolyte. So these metal ions will gain these electrons and then they will form solid metal atoms that will be deposited on the electrode. Then next, combining these two, we can write the overall cell representation for the complete electrochemical cell. Always remember, the first part will be the anodic half cell and the second part will be the cathodic half cell. So in the anodic part we will write metal in solid form. It will produce Mn positive aqueous ions which will be separated from the cathodic part by parallel lines that represents a salt bridge. What is a salt bridge? The salt bridge connects the two half cells so that the two electrolytes do not mix with each other. Then in the cathodic half cell, Mn positive aqueous ions will gain electrons to form M in solid form, that is metal in solid form, which will be deposited on the electrode. So this is the overall cell representation for an electrochemical cell which consists of metal-metal ion electrode. So students, an example of an electrochemical cell that uses a metal-metal ion electrode is the Daniell cell. As we have seen earlier, a Daniell cell consists of two electrodes, that is zinc rod and copper rod, and the two electrolytes that are zinc sulfate solution and the copper sulfate solution. These are examples of metal-metal ion electrodes in the two half cells in the Daniell cell. Now let us move on to the next type of electrode, that is the hydrogen electrode. In this type of electrode, as its name suggests, it consists of hydrogen gas instead of using a solid electrode. So when hydrogen gas is used, there are again two types of reactions taking place in this type of electrode, that is the oxidation and the reduction reaction. When oxidation occurs, the hydrogen gas releases electrons to form H positive ions. These H positive ions mix into the solution which consists of an acid. So there are already H positive ions into the solution. इस solution में already H positive ions present होते हैं और ये H positive ions उसी solution में mix हो जाएंगे. अगर reduction reaction यहाँ पर होता है तो this H positive ions will accept these electrons to form H2 gas, that is hydrogen gas. So that process will be called as reduction process. If this hydrogen electrode is made the anode, then these hydrogen gas molecules will release electrons to form H positive ions into the solution. And if this hydrogen electrode is made the cathode, then the reduction process will occur and these hydrogen ions from the solution will gain electrons to form hydrogen gas which will be released out of this tube. Now when we calculate the EMF of the hydrogen electrode, this EMF depends on two factors, that is the concentration of H positive ions in the solution and the pressure of the hydrogen gas. Now if the concentration of hydrogen ions in the solution is made 1 molar or 1 mole per liter and the pressure of hydrogen gas is made 1 atm, that is 1 atmosphere, then this type of hydrogen electrode will be called as SHE, that is standard hydrogen electrode. These are standard conditions for a hydrogen electrode. If the hydrogen ion concentration, अगर इस hydrogen ion concentration को 1 मोलार या 1 मोल पर लीटर बनाया जाएगा and हाइड्रोजन गैस का जो प्रेशर है अगर उसको 1 atm पर मेंटेन किया जाएगा, इन कंडीशंस में इस हाइड्रोजन इलेक्ट्रोड को स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड कहा जाएगा, that is SHE. In this topic, now let us study what is electrochemical series. As you can see, electrochemical series is a series of all the electrodes arranged in the descending order of their EMFs or the decreasing order of their cell EMF or the electrode EMF. What is EMF? EMF means the potential or the voltage produced by each electrode when taken as a half cell. So now why do we study electrochemical series at first place? There are two reasons behind it. The first reason is electrochemical series helps us to calculate the total EMF of a cell when there are two electrodes taken from this series in the form of two half cells. And the second reason is it will help us to determine which electrode to be taken as the reduction electrode and which electrode to be taken as the oxidation electrode. So these are the two reasons behind the study of electrochemical series. Now there is an interesting statement called low reduces high. So first of all, what is the meaning of this statement? Here low and high represents the values of the EMFs of the electrodes. So when we take an electrode with a low potential or low EMF value, it will reduce the electrode with higher potential value. जिस इलेक्ट्रोड का पोटेंशियल हायर रहेगा सीरीज में जो ऊपर दिखाई देगा, that will be reduced by the electrode which is below in the series. So it will have a lower potential. The lower potential electrode will reduce the electrode with higher potential. So this will help us to determine which electrode to be taken as anode and which electrode to be taken as cathode. यहाँ पर anode और cathode कैसे decide किया जाएगा? जिसका potential low है, that will reduce the electrode with higher potential. तो ये क्या कर रहा है? Higher potential वाले electrode का reduction कर रहा है. So it is itself getting oxidized. So if it is getting oxidized, then it will act as anode, because oxidation half cell is the anodic half cell, and the higher potential electrode will get reduced. So if it is getting reduced, so it will be taken as the cathode or the cathodic half cell. So now after deciding which electrode is cathode and which electrode is anode, it will help us to find the EMF of cell by the formula E of cathode minus E of anode. So in this formula, E of cathode represents the EMF of cathode. The electrode which we had taken as cathode, we will take its EMF value from the electrochemical series and we will put it into the formula. And similarly, we will do it for anode. So E of cathode minus E of anode, this formula will give us the EMF of the complete electrochemical cell. Now let us move on to the topic, the Nernst equation. This topic is very important as it will be helpful in solving the numericals of this chapter. So what is Nernst equation first of all? Nernst equation is useful to find out the cell potential or the EMF of individual electrodes that are used in the electrochemical cell. So this EMF of an electrode is given by E of Mn positive oblique M, and the formula for this electrode potential is given by this equation number 1. So in this equation, this term R represents the universal gas constant which has the value 8.31 joule per Kelvin per mole. Here T represents the temperature in Kelvin. Then N in the denominator represents the number of moles of electrons involved in the cell reaction. When we will write the cell reaction as we had studied earlier, in that the value of N will be the number of moles of electrons. And the last is the square bracket of M. This represents the concentration of pure metal which is taken as 1 molar. This is the standard value for concentration of a pure metal. It will always be taken as 1 molar, and hence the Nernst equation from the equation 1 can be modified as this Mn positive, the concentration of metal will be taken as 1, and this natural log is converted into log by multiplying 2.303 into the numerator. So this was all from today's video. Thanks for watching it, and please do share your opinion about the video in the comments. And do not forget to like, share and subscribe.